Now, moving on, let's see the scales more clearly or closely. As you can see here, we have the numbers 0, 5, 10, 15, 20, 25, and 30. But just to make it easier for you to understand, we put here 2.5 between 0 and 5, 7.5 between 5 and 10, 12.5 between 10 and 15, 17.5 between 15 and 20, and 22.5 between 20 and 25. And we also have 27.5 between 25 and 30. As you can see, the uh, primary division or the major division here is representing 2.5 each. Now, on the voltmeter or as a voltmeter, we have to push out this button here. We have to push it out so that it will work as a voltmeter. Don't forget that. And then we have to set the arrow of the selection here to 3 volts. So we will be using the DC volts 3 volts, and we have to read from number 0 to number 30. And aside from that, after reading, we have to divide our answer by 10. As you can see, there's no 0 to 3, but we have 0 to 30. So, if we put the arrow here or the selection to 3 volts, this means, as I mentioned earlier, this means the maximum voltage that we can only measure is equal to 3 volts. Therefore, we have to think that this is 3 volts, this will be 2.5, this will be 2, this will be 1.5, this would be 1, and this will become 0.5. But it will be difficult for you to just imagine the readings. Therefore, we will still read it normally, as we have mentioned that each of the secondary divisions here will be representing 0.5. Therefore, let's try to understand it more by giving some example. Of course, right now, the needle or the pointer here is pointing to 0. Therefore, we will be reading from 0 to 30. We will use the top scale, the upper scale up, and we will not look, or we will ignore, we will not look at the bottom scale, or we will ignore the bottom scale. Again, the secondary division here are the small lines. I hope it's very clear. The small lines, each one of them will be representing 0.5. And the longer lines here will be representing 2.5 for our major or primary division. That's why this is 5 plus 2.5, it becomes 7.5. 10 plus 2.5, it becomes 12.5. 15 plus 2.5, it becomes 17.5. 20 plus 22 plus 2.5 becomes 22.5. 25 plus 2.5 becomes 27.5. And that's it. This is how we will be reading. And we will ignore, or we will not look, even though it's there physically, we will not look at it, as in we will be reading only at the upper portion or the upper scale. Now let's try this. Of course, the first example here, this will be 0 volt. Now, in the second example, you will see that the needle or the pointer is pointing at the 0.5 or the secondary division here, the first small line, that will be 0.5. So our answer is 0.5. But because you put the selection here as 3 volts, again, the rule will be to divide whatever you read by 10. Therefore, although this is zero point 0.5, we need to divide it by 10, so our final reading will be 0.05. I hope that's clear. If not, let's try again another one. Let's try this one. What do you think will be this number? So again, looking at the normal way, this will be 2.5. But because you selected 3 volts as your limit, then we need to divide 2.5 by 10. So this will be 2.5 divided by 10. We will be getting 0.25 volts. Let's try another one. The number 4, which is after 7.5, but one small line equals 0.5. So 7.5 plus 0.5 will be 8. And so we divide 8 by 10 as the rule for 3 volts. Then we will be getting 0.8 volts. For number 5, what will be the reading? This will be from 17.5. This will be 18. This will be 18.5. This will be 19. And this will be 19.5. And then you will go ahead to 20. But you are pointing here, so this will be 19.5 divided by 10. We will be getting 1.95 volts. You see, the reading way, or the way we read the analog meter, is really hard because you need to be aware, or you need to know what voltage limit did you choose over here. Now, if you did not see the voltage limit, then you will read this as like 19.5, and that will be impossible because the limit is only 3 volts. So you will not be getting 19.5 in your reading. So the best reading will be lower than 3. All your answers must be lower than 3. So 19.5 is impossible. Therefore, something is wrong. You have to remember the rule. We have to divide by 10. So we will be getting 1.95 volts. Now, in the next one, how about this? What do you think is this? So, looking at the top, this is 20, right? Plus 0.5, that will be 20.5. Plus 0.5, that will be 21. 20.5, 21. Plus zero point 0.5, that will be 21.5. But I think this is between 21 and 21.5. So, it will be read as 21, half of zero point 0.5, that is 0.25. Therefore, we will be getting 21.25. But we need to divide it by 10. So, we will be getting 2.125 volts. Now, this one is between 25 major division and the 0.5 here, which is the secondary division. So, it's supposed to be 25.5 if it falls on the secondary division over here, but I think it's between 25 and 25.5. So half of 0.5 is 0.25. Therefore, this would be 25.25. Let's see. Yes, it's 25.25 divided by 10. We will be getting 2.525 volts. And finally, I hope you know this. This is what? Yes, you're right. This is 30. But because your maximum is only 3, what will we do? We have to divide our answer 30 by 10. So, we will be getting 30 divided by 10. The final answer will be 3 volts. Again, you can watch this video so many times until you understand what is or how to measure or how to read an analog scale. Just try to see one, for example, here, and then try to write your answer, and then you can check if your answer is right. You can pause the video or you can look at it first and then write the answer and then check your answers. Just practice reading and you will see later on, you will become more familiar about it. Now, moving on, let's see the next example. As you can see here, we changed the position of the limit for our voltage as 30 volts. So, the limit is 30 volts, therefore, it's okay to read the values 0 up to 30 without doing any multiplication or division. Let's try the number 2 using the same way or using the same pointers. So here, it's pointing on the first, which will be 0.5, and we will not do anything. This will be 0.5 volts. For the third example, this is 2.5. You don't need to divide or multiply. Again, why? Because you selected 30 volts for your limit, which is exactly the limit in the top scale here, which is also 30. So no need to divide or do anything. Just read the pointer like here. What do you think is this? I think this is 7.5 plus. It's not really in the middle, so it's closer to the first secondary division here. So this will be 7.5 plus 0.5. We would be getting 8 volts. And then the next is, again, don't be confused. Do not look at the bottom. Ignore these numbers, 6. Just look at the top. So 17.5, 18, 18.5, 19, 19.5. Correct, 19.5 volts. How about this? 20, 20.5, 21, but between 21.5 and 21, so 21.25 volts. And then we have here between 25 and 25.5, that will be 25.25 volts. And finally, we have exactly on 30. No need to do anything because our maximum is 30 volts. Therefore, we can have an answer of 30 volts. Now, moving on to the next example, let's move the pointer or selection to 300 volts. Although we don't usually measure 300 volts DC, let's practice here. So we will be getting, again, 0.5, same answer, but the maximum is 300. Therefore, the 30 here will not be 300 unless we multiply our answers by 10. And so, the first one will be 0.5 multiplied to 10. Therefore, the rule, if you put the selection to 300 volts, you have to read from 0 to 30 and ignore the 0 to 10, or don't look at it, or don't never mind it, I mean. And then you have to multiply your readings with 10. Like here, if it is 30, you have to multiply it by 10 to get 300. So, the first reading here is 0.5. You have to multiply it by 10. Let's do the next one. What is this? Again, this is 2.5. But you multiply it by 10 and you will be getting 25 volts. How about this? This is 7.5 or plus one small division, 0.5. So that will be 8. Multiply by 10 or multiply with 10, we will be getting 80. And this one will be 19.5 multiplied by 10, that will be 195 volts. Here we will get 21, or 21.25 multiplied to 10, we will be getting 212.5 volts. Number 7 will become 25.25 multiply with 10, we will get 252.5 volts. And finally, we will be getting 30, but we should not write 30. Why? Because our selection here is 300. And the limit is supposed to be 300. So we have to multiply it by or with 10 and we will be getting 300 volts. I hope that's clear. How to use the 3 volts limit, the 30 volts limit, and the 300 volts limit. If you still don't understand it, then you can try to watch this video again and again until you understand it. But you have to practice reading analog values because if you will be working in a company or in an engineering company as an electronics communication or instrumentation or electrical power engineer, then you need to know how to read analog meters. Although the digital meters are easier to use, this one you have to practice also. Now let's move on. Let's try to do the 10 volts limit. Let's see. So if you put the selection to 10 volts like here, you will now be ignoring the 0 to 30 and you will be reading from 0 to 10. So do not read from the top scale. You have to use the bottom scale or you have to ignore the top scale. And so I put here a guide that the zero point 0.2 each for the secondary division. Before we use 0.5. Now it will be 0.2. So there will be a shift or a change in our minds how to read the small lines. And the longer lines will be the major division, which will now be 1 each. So every line will be 1. That's why I put a guide here. This is number 1, number 2, number 3, all the long lines at the bottom up until number 10. Now let's try the first one. Remember, this is 0.5 at the top, but we will be ignoring the top scale. So you have to read from the bottom. And at the bottom, I have told you that this is 0.2. This is no longer 0.5. I hope you understand that. And the good thing here is that the limit is set to 10 volts. Therefore, the limit here is also 10. Therefore, you don't need to do anything. You don't need to multiply or you don't need to divide anything. Just read it directly on the scale. Like number 3, what is this? So let's try. Let's count from here. This is 0.2, 0.4, 0.4, 0.6, 0.8, and then we have 1. But I think the line or the needle or the pointer is between 0.8 and 1. Therefore, between 0.8 and 1, that's 0.9. So most probably this is zero point 0.9 volts. Let's see. Yes, we are correct. That's 0.9 volts. How about number 4? So from number 2, 2.2, 2.4, 2.6, 2.8. So I think this is 2.8 volts. Let's see. Correct. This is 2.8 volts. Number 5. This is 6, 6.2, 6.4. Therefore, this is 6.4 volts. Number 6, exactly on the 7, so this will be 7 volts. And here we have 8, 8.2, 8.4, so this is 8.4 volts. And number 8, it's not exactly on the 10, but let's just say that if the pointer is really near the major division or any division there, you don't need to think about dividing it further aside from the half of the line. So we will just consider this as 10 volts. Again, don't write 30 because you put the selection to 10 volts limit. Okay? Now, if you understand this, we will be using the same pointers, but we will be changing the selection not on 10 volts, but we will put it at 100 volts. Let's try that. Yeah, in the 100 volts here, what happens is that number one is still zero, but number two is not zero point 0.2 anymore. We have to multiply it by 10 to get 2 volts. And number three will be zero point 0.9 multiplied by 10. We get 9 volts. We have 2.8 on number 4. 2.8 multiply with 10, 28. We have number 5. 6.4 multiply with 10. It will be 64 volts. 6 multiply to 10, or sorry, 7 multiply with 10, it will get 70. Number 5 is 6.4 multiply with 10, 64 volts. Number 7 is 8.4 multiply with 10, we get 84 volts. Number 8 is 10 multiply with 10, we get 100 volts. So this is how to read the 100 volts selection. Again, we cannot get 10 here because we set it at 100 volts. So whenever you put the selection to 100 volts for our voltmeter, analog voltmeter, we have to read from the bottom 0 to 10, and we have to multiply our readings with 10. So you have to practice that.